Hello, I would like to introduce Jan Bosch from Sweden, who is at FedCSIS conference presenting digitalization process.
Thank you, Tomasz. I'm really delighted to be here.
Well, the first question I would like to ask you is about the operating systems, actually. Operating systems manage key resources of a computer system, and in your presentation you're saying about operating of digitalization process, operating systems for digitalization process. So which key resources require management in this area?
Yeah, so the title of my talk is Towards a Digital Business Operating System. And of course, I draw a parallel to computer operating systems. But if we look at traditional business operating systems, companies are typically organized in hierarchical management structures. They typically operate based on waterfall development processes. They tend to make opinion-based decisions, and they try to do as much as possible in-house. And what I try to raise in my talk is that I see a fundamental shift happen in industry, where we change everything. On the first hand, we drop waterfall, and instead we move to agile practices, we move to continuous integration, we move to continuous deployment, and what we see is that there is a very fast feedback loop. So that's the first thing. The second is we move decision processes from opinion-based to data-driven. So instead of, I have been 30 years in this industry, I know exactly how this works, I run A/B experiments to figure out what works better for customers, and then I can make data-driven decisions. The third is, our research shows, as I will show in my talk, that 80 to 90% of all resources in R&D work on commodity functionality. So stuff that no customer actually cares about, you just need for your system to work. And what we believe is, and our research shows this, that by focusing on your business ecosystem and the software ecosystem around you, you can free up the resources, your own resources, and focus them on the things that you are uniquely good at, and instead focus on the ecosystem around you in order to focus on, to have them do the things that you don't want to do yourself. And then finally, I believe that organizations, hierarchical organizations, are going to be a thing of the past very soon. Instead, we're moving to much more empowered and autonomous organizations where people don't have bosses, but rather people operate in teams, they have quantitative output metrics, and they manage themselves based on what expectations they are looking, what metrics, what data-driven metrics they're looking to optimize for. So those are the big themes that I look to cover in my talk. And then there is one thing, if you allow me to add to that. Of course, artificial intelligence is a big topic that comes up a lot. So I will talk a little bit about our work on machine learning and deep learning, and how we see that machine learning and deep learning really requires a significant engineering approach in order to build mission-critical and production quality solutions.
Okay, and is any of these areas more important than any of the others?
It's not that they are more important to each other, it's more that our experience is that in order to be successful, a company first needs to focus on the speed dimension. So that's very important, because the speed dimension requires you to build up a fast feedback loop in the organization. Once you have that fast feedback loop, you can start to move to data-driven decision making, so then data becomes more important. And then once you have data in place, it becomes easier to make quantitative, informed decisions about what should you do inside the company and what should you do outside the company. The fourth dimension around empowerment, moving away from hierarchical organizations to more empowered or autonomous organizations, that is something that runs in parallel with those three dimensions, because if you look at agile development, that's already a first step towards a more empowered organization. Agile teams have a lot more autonomy than traditional teams in traditional development approaches.
Okay. Well, the unavoidable part of any digitalization process is joining different software, which was created in, I would say, different points in time by different people. So how to merge all those puzzles that are typically not compatible with each other?
Yeah. So what we see in the companies that we work with, and as I'll talk about, I'm a director for something called Software Center, which is a collaboration between 12 companies like Volvo and Ericsson and Volvo Cars and Saab Defense, but also Boeing, Bosch and Siemens, just to mention a few. At 5 universities, what we see in the companies that we work with is that the amount of technical debt that has been accumulated in these companies, both in their product software and also in their information system software, is often quite high, to be very honest. And in our research and in our collaboration with the companies, we focus on finding effective mechanisms to balance resources between, on the one hand, feature development, which of course still needs to happen, focus on quality management, so defects, managing defects, etc., but also finding enough resources to manage technical debt. So the interoperability question that you talked about, how do we actually bring software that has been built in different generations together, is actually a question of how do you effectively manage technical debt and how do you prioritize technical debt management high enough vis-a-vis feature development and quality management. And what we see is that when companies start to develop in or start to invest in technical debt management, many of the problems that you were talking about are going away. So then things become a lot easier to manage.
Okay, and I would say that another layer above that is maybe the fight with the users, because the user level will resist on those changes. They are used to solutions they are working with for, let's say, 15 or 20 years, and right now there is some digitalization process which removes them at all, or which forces them to use something which is different. So how to avoid, for example, different meanings for the same things in different departments, simply?
Yeah, and I think that that's a really good question. And what I see is that the customers of the companies that I work with are hesitant about taking in new releases for two main reasons. The first is they have a bad experience from a quality perspective, so that the new release of software often initially has many quality issues. So that's one of the reasons why customers are very hesitant to adopt new versions of software. And the second part is that often there is an enormous change in the user interface between the old version of the software and the new version of the software. Now, what we see is two things. The first is because of the adoption of continuous integration and continuous deployment, we get to a situation where the quality of the software at the time of release is actually much higher than what it was in the past. So customers are experiencing much fewer issues on the quality front than they did earlier, which allows companies to and customers to be more willing to use continuous deployment. The side effect of that is that because I release new software very frequently, the amount of changes and the magnitude of the changes in the user interface is much lower than it was in the past. And then there is a parallel situation, which is that in many situations, companies are moving from products to services. So rather than me buying a product and now the product is mine, instead I buy the same functionality as a service. But the moment I buy functionality as a service, it is the producer of the functionality that can decide when do I do the next deployment of the software. It's not the customer anymore. You don't need permission from the customer, because you're offering the service, and if you have the plan to update on a bi-weekly basis, you update on a bi-weekly basis. That's just the way it goes. Yeah, so what we see is that because of the increased quality, because of continuous integration, and the increased deployment frequency of continuous deployment, we see that customers typically have much less resistance against these new releases because they don't run into quality issues, and the usability changes are so small that they basically take them in stride.
Well, so digitalization process replaces, I would say, the weakest part of the whole process, which is the so-called protein-based interface between the monitor and the keyboard. So we are trying to avoid problems that are caused by people who are not algorithms, who are not repeatable. But where is it all going? Do we have any stop point?
Well, I mean, as far as I believe, and I hope, because I'm a hardcore modernist, is that technology development and the increasing of the well-being of mankind will continue forever. But to go to your point, one of the things that I now see happen is that earlier many IT solutions were built to support humans do a better job. And if we look at many of the new IT solutions, we see that those software solutions are basically used to replace humans altogether. I mean, one of the companies in Sweden, Volvo Cars, together with some of its partners, is working very hard on self-driving cars. Once we get self-driving cars on the road, you could complain about all the drivers, taxi drivers, truck drivers, etc., that will be out of a job. But you can also look at the fact that I think in the US, I think the number is something like 30 or 40,000 people a year die in traffic accidents because of human errors. Yeah, those deaths are going away, at least to the large extent possible. So I think that there is a huge societal benefit to these things as well. Now, it will mean that people with lower educations and people that do jobs that are highly repeatable are at most risk of being disrupted by software solutions that basically automate what they used to do manually in the past. And is that going to lead to societal transformations? Yes, that's going to lead to societal transformations. But in my view, and I know that many people feel different about this, this is a process that has been going on forever. I mean, I think you know that the word computer used to refer to a person that was actually doing manual calculations before the computer as we know it today was introduced. So I think we're going to see many of those transformations. I think that more than half or 80% of all the job titles that now exist didn't exist 50 years ago. Yeah, so what we are going to see is a fundamental reinvention of what it means to have a job and what are the prerequisites for being a job. But if you're watching this and you have a job that is highly repeatable, which makes it easy to automate, I really would think carefully about how to prepare myself for a future where my current job is being completely automated, which means I need to get ready for something else.
That's for sure. It's we will face, as you said, significant societal changes. But what I would add is that I think that in IT environment we tend to remove as much work from our side as we can. So once we remove all the problems that nowadays arise on the level user maintains side of IT, don't you think that we'll start maybe moving forward so that we'll start reducing the maintenance side just to have less work on everyday basis?
That's an interesting one. So if I look at the work that we're doing, we are seeing going forward that there are 3 types of software development taking place. The first is what we call traditional requirements-driven development. You have product management throws requirements over the wall, and R&D basically builds it. We've done that for a very, very long time. The second type of development is what we call data-driven development. And data-driven development is concerned with running A/B experimentation and using data to decide what is a better implementation or not. The third type of development is what we call AI-driven development. Then I have large data sets, and what I do is I use those data sets, which typically are labeled, to develop deep learning models or machine learning models, and those machine learning models are basically then taking the job they trained, so I don't have to actually build or program them in the traditional sense of the word. So if you talk about reducing maintenance, what I see is that the more work we move from traditional requirements-driven development towards AI-driven development, the easier it will be to maintain and evolve the models, because all we have to do, and this is a bit of a simplification, is take the new data, retrain the model, and have an evolved version of the model deployed in the system, which will, of course, remove quite a bit of maintenance effort. Having said that, the amount of software in the world is still going up very, very rapidly. So I think that the total volume of software maintenance that will have to take place is still going up. It's just that per line of code, the amount of maintenance that we need, effort that we need to invest may actually be going down. So that's my current assessment from where I'm sitting.
Okay. Well, I was asking about it because, in my opinion, we're very, very close. A few times we're very, very close to a point where the software itself was maybe crossing the border after, well, you know, on the other side of it, of which people could not decide for the software what the software is going. For instance, we had a situation when the software implemented its own programming language and nobody knew what's inside. So, well, we were very, I said, we were very close to the point because they were able to switch it off. They could decide yet. But what if we miss that point and if the software develops so hard that it will be able to block any such requests from the people, because it will treat all the people as users, just as the IT specialists right now treat all the other people, you know, non-IT.
So I'm not quite sure what you're getting at, but what I have seen in some of the companies in Sweden is that the complexity of the systems that we're building is so large that there is no single individual anymore that understands the entire system. And that, I think, is a reality that we just have to go and live with. I also do think that it reinforces the importance of investing in technical debt management with the intent of maintaining or reducing the complexity of the system overall. I mean, very often finding the right abstractions goes a long way to making a system or keeping a system understandable for everyone involved. The second interpretation of what you just said is where some people are really afraid of AI taking over the world and basically replacing mankind with the next version of intelligence. That is something that, based on what I've seen in the deep learning, machine learning and AI space, I'm on the board of a company in Stockholm that is in this space, I think if that ever is a risk, it is many, many decades away from what I can see. I don't see us reaching a state of complexity where AI solutions would be able to take over what we are currently running as humans. But the way that we engage with our systems is changing.
Okay. Well, I think that it's not two options, that they're both very strictly or strongly connected with each other, right? So it's if people are afraid, but at the same time, a very important part of that is, or maybe the reason why it is possible, why they are afraid, is that the systems that we build are becoming more and more complex, more and more sophisticated, and as you said, nobody at the moment controls the whole system. Nobody is able to understand what it is doing as in total. So specialists are focused on some parts or on some architectural level on a whole, but in details, nobody copes, you know, the whole system in very, very deep details. So
there are two sides that I want to add to that. The first is we have complexity theory and chaos theory as ways to think about that. And what I still see, and we see this in human societies, because also human societies are very, very complex and nobody really knows how to deal with them. Very often I see people come up with very naive solutions on how to address a certain problem, without understanding that introducing such a solution may have so many negative side effects that we run into a situation that the resulting outcome is very, very poor. Yeah. So, especially when we talk about introduction of new laws in societies, we very often see that the intended outcome of the law is never achieved, and that there are lots of negative side effects. And what I'm personally propagating, but this is me as an individual, is that rather than just saying we want a certain law that we think will accomplish X, Y, or Z, is that we say we want this outcome, We think that this law will be an experiment to test if the outcome is actually achieved. And if the outcome of the intended outcome is not achieved, we basically undo the law and try something else. Yeah? And that is the typical situation in the complexity theory and chaos theory, that you have to try out things in order to study all the side effects before deciding whether you're doing the right thing or not. Because it's very easy to beat yourself in your chest and say, I know everything. But the point is, in many situations, we do not know everything. We only know what will be what the effect of something will be is after when we try it out. And in order to try something out, we also need to be able to undo it in order to avoid the negative side effects. Having said all that, I do want to remind everyone who's watching this, because I run into way too many postmodernists who believe that the world is going to hell in a handbasket and that everything was much better earlier. We are living in the best time, the best point in the history of mankind. From all kinds of quantitative metrics, if you look at poverty, if you look at war deaths, if you look at life expectancy, if you look at discrimination, everything has enormously improved over the last decades, and many people have to be mindful of that this is to a large extent due to the technology developments that we have been experiencing. Yeah, if we look at life expectancy between 1970 and 2000, and I think 2012, life expectancy worldwide went from 47 to 70. Yeah, so that's a 50% improvement in life expectancy over such a short period of time. I think something like 50 or 60 years. Yeah, so we're talking about enormous improvements that we have experienced across the world. Yeah, so everyone can be afraid of technology and can be afraid of the changes that are happening. But the fact is, we're living in a much better world than what we have lived in for a very, very long, ever. I mean, it has never been better than what it is today. And I personally, for all the issues and concerns that people are raising, don't see why that progress would stop.
Thank you for conversation.
Thank you very much for giving me the opportunity to share my perspective.